Hey, what's up, guys? This is Chung here. So today, let's take a look at the latest biweekly contest problem, number 1639. Number of ways to form a target string given a dictionary. I mean, this is like, I think it's a standard hard problem. So you're given like a list of strings of the same length of words. Okay, so keep in mind, so each word has the same length and a string target. Okay, and your task is to form the target string by using the letters in this list of words under the following rules. So the target should be formed from left to right. So this should tell us we can use an index to track the current matched target string, right? And then the second one is that to form the ice characters, you can choose any case character of the J strings in the words. Basically, we have words one here, right? So we have words one, word one. We have let's say we have four strings. Each word has like four strings, four letters. Okay, three, right, and then so on and so forth. So it says that anytime when you choose, like for example, if we choose this one to match our current target string, after you choosing this one, anything on the left, including this one, anything on the left, including this one, cannot be chosen anymore. So it means that once you chose this case index on any of the word here, you can only choose k plus one, starting from k plus one letters later on to form the remaining target strings, and repeat the process until you form the string target. And then it asks you to find the total number of ways you can form the string. Yeah. So by looking at this problem at the first glance, right? So it's pretty obvious. We're gonna use like the top-down DP, right? So the top-down DP here, the first parameter is gonna be the what? Obviously we need two parameters. The first one is the target index, right? So we need a target index that's telling us like basically before this target index, everything has been matched uh, uh, for this target string. And the second one is what? Is the word index, right? It's a word index. So this one tells us from which index we can are the valid strings we can pick, right? So that's the two parameters we need here. And but if you just use the brute force way, like let's say basically every time we have targets index and we have word index, we're gonna loop through all the words, right? So basically we can loop through all the words with the same word index. If we find a match, right, then we just accumulate that. We just do a DP this target plus one and the word index plus one, and then we do everything for all the words here. But that's gonna be a waste of time, right? Let's say we have a thousand words here, right? So and let's say each of the words has the same letter here. So which means that we have to loop through every time when we need to match the target index here, we have to loop through the entire words. That's gonna be it will TLE basically because the word's length is 1000. So which means that at each state we'll loop through make a 1000 times for loop, right? So how can we improve that? So the improvement is pretty straightforward. As you guys can see, I mean basically if we have like at the same index here, and let's say we are matching the current index is letter E, and uh, let's say we have four E's on this index here. Let's say we have one E, two E, three, and four. Let's say we have four E's here. So what does it mean? It means that we can at the current index we have four ways to pick the letters that can match the current E here. So which means that we can simply use the count, right? and then we multiply by the DP that we'll be doing later on, because anything that's after this one here, right? Basically, we have four branches here, and each branches will lead to the same of DP here, and in total we have four times the DP at this index. Yeah, and then we can just that can simply like remove that for loop to loop through all the word. We can simply use the count at each of the index here. Yep, basically that's the idea. And to do that, we can just do a pre-process, right? So we do a pre-process, we have a count dictionary. We have a count of a list of dictionary. So at each of we have a count here. So the count is the length is the same as the length of each words, and of each here, and each element is a dictionary, right? So it stores at each of the index here the counts for each letters, so that later on we can simply use this count list of dictionary to help us find this four here. Yep. Yeah, I think that's pretty much the main idea here. So let me I'll do the coding here. So we have 10 to the power. And yeah, so in the end, it asks us to do a modular by this big number. Okay, so 9 plus 7. Okay, so that's that. And since we need two index, I will be defining the two length first. So I have a target. The first thing is the target length. And I'm going to have a uh, target length, right? So target length equals to the length of target. And then we have a word length. I have a word length equals to the length of the word 0, right? Because each word has the same length. Okay, now the count index here, right? The count list here. So and each element is each element is a dictionary. So I'm going to do a default dictionary of the index the integer for in range of the word n, right? Because for each of the index here, each of the index of this word, we're gonna have like dictionary to count the total numbers. And then I just simply loop through the in range of w the word n, right? So for each of the index, we loop through all the words in words, right? And the current letter, that's the current letter of the words is the w of c, sorry, w of I. That's the current, that's the current letter, right? The current character here. So and the current character is going to be the key, okay? And the value will be increased by 1. So this means count. So first we find the dictionary at this index here, right? And the key will be the C, right? And then we just do a +1 here. So that will be the pre-processing for the count. And in the end, we simply return the DP at 0, 0, okay? And do a modular, right? So that's when we need to implement this DP function here. So we're gonna have like DP of the target. The first thing is the target index, right? And the second one is the word index, right? So that's that. And uh, yeah, I'll be implementing that memorization as well. So memorization is equals to this, right? It's going to be a dictionary, and if right target word index is in the memorization, right? I simply return this. Term memorization, that's that, right? And then I'm gonna have the answer. Answer is gonna be accumulated numbers of ways to form this index, to form this target. So, but I'll finish the structure here first. I mean, this is this one. So in the end, I will be assigning this one answer to this one, and then we return the answer. Okay. So that's the that's a template, or you can use this, right? Or how are you cache equals to none, right? That's basically a shortcut of removing this kind of memorization stuff. But to make this code like language agnostic, I'll be implementing this one anyway. So now we have what? We have the current letter. So what's the current letter? So we need to match the the target of the target index letter. So that's the current character we need to match, right? And you know, there are like two ways of doing this, because I was trying to do the what, I was trying to do this. I was trying to do a for loop here for the I in the range of the word index, right? And to the end of the word n. I was trying to do this. Basically, I try all the possible index from the starting point to the end, and then at each location I try to do this like the state transition. But this turns out to be quite slow because we have for loop here. And a better way of doing this is we should try to avoid doing this for loop here, and instead we should just basically, actually, this one, it's actually the meaning of this is we are trying to skip, right? I mean, if let's say the I starting from this one to the end, right? Basically, it means that we could start from the word index, or we could start from the index, or we could start from the word index plus one, or we start from plus two, plus three, plus four, right? So it means that if we start from four, it means that we're skipping the first three indexes here. But if we're using this way, it will be TLE because we are actually using a for loop here. So a better way of doing this is that we simply do a what? If we decide to skip the current index, we'll just do this. We'll just do an answer equals to dp target index and the word index plus one. So here we decide we skip current word index. That's a better way so that we can just remove this for loop at each of the state. That can save us a pretty significant amount of time here, right? So that's that. And then now this next one is try to use current word index, right? And this one line will take care of skipping all the index because when the next time it comes to here, it'll also skip this one, right? And then skip, 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 and this will take care of all the skipping cases. Here we're trying to use the current word index. So and here we can simply check, right? If the C is in what? Is in the count of the word index, right? Because we already have this count for each of the index. And here we simply check if the current matching letter exists in this count, a dictionary for the current word index, right? If that's the case, then we know, okay, there are some potential matches we can find here. And then we simply do answer plus dp of target because we have find a match. So we'll be increasing this target index by one. And of course, we'll also increase this word index by one, right? So that's a DP transition function here. And then, like I said, and then we simply can multiply by the count of the word index and then the C, because this will give us the numbers of the C that appears at this index, right? Yeah, cool. I think that's everything. Yeah, let's try to run the code here. Oh, sorry. Ah, stupid mistake here. Sorry, I totally forgot the base case. I'm so sorry. The okay, so the base case is, of course, the first one is if target index is equal to what? Equals the target length here. It means that we have matched all the targets, and here we can of of course we need to return one. Okay, because we have find one solution, right, to match to form the target string here. And another one is this, right? If the word index is equal to the word length, it means that if we didn't find it and we have reached the end of the index of this word here, then it means that there's no match and we'll return 0. Yeah, so that's the two basics base case here. Yep. And let me run the code again. What did I? Oh, sorry, I think I spelled it out. Target and the word n. Sorry, target and the word n. Yeah, cool. So let's try again. All right, accepted. Submit. All right, cool. So it's accepted. All right, so I mean, pretty straightforward and with a bit of tweak here, like this pre-calculation of the count at each index, right, for each letter. And so, oh yeah, the time space complexity. I think this is pretty straightforward, right? So the time complexity is the same as the, the total combination of these two, right? Which is the let's say this is m. Oops. Yeah, I don't know what happened to my drawing software. Sometimes just do just do some weird stuff here. So let's say this is m and this is n, right? So the total state combination is like the what? So the time complexity will be the O of m times n, right? And space complexity is also O of m times n because of this thing here, the same, because it will call this number of dp functions here, right? And here it's just like a pre-calculations, right? So yeah, actually this is also like a m times n. Okay, yeah, yeah, but it won't affect the final result. Cool. Yeah, I think that's it for this problem. Thank you so much for you guys to watch this video and stay tuned. See you guys soon. Bye bye.